Welcome you to this lesson. Teacher Katimbo Richard teaching mathematics, P5. Today we are continuing with the same topic we are dealing with in the previous lesson, that is operations on whole numbers. And today in particular we are looking at bases in P5 term 1, which work. It's going to be found on page 61 up to 66 of your workbook. That is P5 term 1. So you are free to follow that book as teacher discusses, then thereafter you answer all the activities. So we are looking at place values of other bases, and the examples are here, and the general instruction is, or the general instructions are: state the place value of each digit in the following numbers. State the place value of each digit in the following numbers. Part A says 2, 3, base 5. Now that you are told to write or state the place value of each digit, you do like you see. You write 2, 3, base 5, and then you say the place values are 1s, 5s. 1s, 5s. Should be noted that all place values end with letter S regardless of the base. So say 1s, 5s. Remember in base 10 we had 1s, 10s. Now being base 5 we go 5s. So you say 1s, 5s. And this is the answer because you have stated all the place values per digit that forms this number. Remember, this number is read as 2, 3, base 5, not 23, base 5. No, we read a digit after another, that's 2, 3, base 5. And you will be perfect in that reading. Then part B, state the place value of each digit in this number. 3, 2, 1, base 5. Like it is in part A, it is base 5 in part B. So you write 3, 2, 1, base 5 and start stating. You say 1s, 5s, then 5 5s. Say 1s, 5s, 5 5s. And that is the answer to the question. Then part C tells us to state the place value of each digit in 1, 2, 3, base 6. This time it's base 6. You say 1s, 6s, be careful, there is E. Don't just add S this time like we did with 5s. So say 1s, 6s. The spelling of 6s is S-I-X-E-S, like you see. Then 6 6s. 6 6s. Sometimes people put a hyphen here. There's no problem with the hyphen put in between there. Hyphen is like a minus that connects two or more words to make one word, so that is 6 6s. And that's all. Note, in basics we add ES at last, not just S. If it is base 4, you say 1s, 4s, 4 4s, 4 4 4s, like that. If it is base 9, you say 1s, 9s, 9 9s, 9 9 9s, as you continue. So in short, in every place value, the first place, in every base, the first place value is 1s, then you go to a base. So we say 1s, 6s, 6 6s, because of this basics. That way, you have learned how to locate place values in a given base. Then now we are going to look at expansion in different bases. Expansion in different bases, or in bases. Now you will note that bases can be expanded in two ways. One, using place values. Then two, using powers, which powers are also known as indices, or exponents. When I say expand using powers, the same as one being asked to expand using indices, and the other, on the other hand, someone can be told to expand using exponents. So we use two ways in these other bases. That is, we expand using place values. We can as well expand using indices or exponents or powers. Whereas in base 10, there are three ways. You use place values, you use values, and use exponents. But here, in these other bases that are not base 10, meaning non-decimal bases, we are using two ways, using place values as well as powers, particular base. As the examples are coming your way. So the instructions say expand the following as instructed in brackets. Expand the following numbers as instructed in brackets, meaning we shall have different instructions as these two ways of expansion. So example number 1 tells you to expand this 4 to base 5 using place values. Expand 4 to base 5 using place values. Because you are being instructed to use place values, use your place value knowledge you have acquired today. Write your 4 to base 5 and then show the place values. So the first place value is ever ones, so we say ones, then 2 is under 5s. Now use these place values you have learned to expand. Now we say 4 times this 5, so 5s is turned to a 5 in working here, that is an expansion. That is 4 times 5, put in brackets like this, plus this is 2 times 1, and then that's all. You underline and that makes the answer that day. So you do underline and that is the answer to that question. In so doing, you have expanded using the place values of 1s and 5s that constitute this number 4 to base 5. Ensure you use them. So that's why you first learn the place values and now we are putting them to use. This is the answer to that question. And then we go to example number 2. Expand 2, 3, 1 base 4 using exponents. Expand 2, 3, 1 base 4 using exponents. Remember, exponents are the same as powers and they are the same as indices. So when you're told to use indices, please, it's the same as being asked to use exponents as well as powers of that natural base. Which base you have in number 2 is base 4. Now, in this number, we draw a table that has got boxes equaling to the number of digits that form that number. So the digits are 2, 3, 1. Now, how many digits are they? 1, 2, 3. So we draw 3 boxes and then fill in 2, 3, 1. Then down, write the base. The base is 4, write 4, 4, 4. And if it is 5, write 5, 5, 5. If it is base 6, write 6, 6, 6. Then show the exponents or the powers or indices. 4 to power 0, 4 to power 1, 4 to power 2. You must note that we write to power 0 from the 1's place value as we go forward, then 4 forward. So we say 4 index 0 or power 0, and here 4 index 1 and then 4 index 2. And these are the indices or exponents or powers that we are going to use to expand. Having drawn this table, then write the answer. We say 2 times 4 index 2. Put in brackets, index 2 is this one, to power 2. Then plus 3 times 4 index 1. Like that, put in brackets, then plus 1 times 4 index 0. Like that. In so doing, you have answered that question of expansion of the same number using powers or using exponents or using indices. You underline and that's all Now that same idea of expansion is going to help us to change those bases to base 10. That's why the next subheading or subtopic says changing bases to base 10. How does one then change other bases to base 10? So the answer, by expanding them. You can expand using place values like we've done here. You can as well expand using powers and now later evaluate. So having learned how to expand, then you can change bases to base 10. Now the examples are here. The instructions say change each of the following to base 10. Change each of the following bases to base 10. Like change 3 to base 4 to base 10. I said we expand. We can either expand using place values or exponents. Now I've opted for use of place values like we did. This is 3 to base 4, whose place values are 1s, 4s. First expand and then evaluate. When you evaluate, or when you get the value of what is expanded, the answer will be a base 10 numeral. So first expand, now 3 times 4, like that, in brackets, plus 2 times 1. Now, expansion is done. What about now converting to base 10? Get the values now. 3 times 4 is a 12, plus 2 times 1 is a 2. Now I've got 12 plus 2. Which 12 plus 2 is a 14. So when you get this 14, it will be the base 10 and it will be the answer. So 3 to base 4 is equal to 14, base 10. It should be noted that base 10 is read normally. We read it as we've been reading all the figures. Don't say 1 to 4 base 10, we say 14 base 10. Then the other bases, we read a digit after another. Like you see 3 to base 4. Never say 32 base 4. No, that is contradicting oneself. When you read 32, just know that is base 10. So, and you should note that a number without a base is automatically in base 10. So when I say 14 without base 10 or without writing the base, will be meaning 14 base 10. Whereas these other bases, the base must be there for it to bear meaning. There is no way you can write 32 just at once and you think it's a base 4 numeral. As soon as you say 32, that's base 10. But now this is 3 to base 4, whereas this is 14 base 10. So learn how to read the bases also. As we continue with example number 2, that says change 1, 2, 3 base 5 to base 10. Change or convert 1, 2, 3 base 3 to base 5. Like I opted for expansion using place values. We start. We say 1, 2, 3 base 5. And now the place values, as we've learned, are 1s, 5s, 5s. Then you are going to expand. That's 1 times 5 times 5. That's what is written here in brackets, plus 2 times 5, so also in brackets, then plus 3 times 1, also in brackets. And now you evaluate. If a question told you to expand or asked you to expand, you stop here. But now it is by way of expansion that one gets to reach base 10 from any given base. So we expand and then evaluate. So I've expanded. If it's just expansion, we're writing this one. Now get the value where 1 times 5 is a 5 and 5 times 5 is a 25. Then 2 times 5 is a 10 and 3 times 1 is 3. We are then going to add 23 plus 10 plus 3. So we first add these two, that's why the brackets are here. That's 25 plus 10 gets 35, which 35 plus 3 gets 38 in base 10. Remember, with or without the base here, the answer is correct. For base 10, When you don't put a base, the number is already base 10. So that's why we reach 38, not 38. We say 38 base 10 is equivalent to 123 base 5. And that's how we change from other bases to base 10 through expansion and evaluation. So we evaluate to get a value of those in brackets now. So what is the value of 1 times 5 times 5 is 25. The value of 2 times 5 is 10. And the value of 3 times 1 is 3. And then evaluate the addition, where 25 plus 10 is 35. And then plus 3 gets 38 base 10. And that's how we find it. And now we are going to see how one can convert from base 10 back to any other base in question. That's why the next subtopic reads changing from base 10 to other bases. Changing from base 10 to other bases. Remember, in the previous examples, we were looking at how one can change from other bases to base 10. Now, the reverse is true. We are changing from base 10 to other bases. Look at these examples, then be able to answer that work all the way from page 61 to 66 of your workbook, this class P5. Now, examples, and the first example says, change 34 base 10 to base 5. Change 34 base 10 to base 5. Wherever I've got base 10 to any other base, now that base 10 is the biggest base, is the mother base, is the decimal base, we do divide. We use base number remainder to divide. Base number remainder, this B means base, N means number, and R means remainder, of which the remainder will make the answer as we are going to see now. Base number remainder, which can be memorized as banana never rot. Many of you that are enjoying eating the banana will normally say banana never rot, so that you remember that B stands for base, then N means number, and that R is remainder. Base number remainder is the actual meaning, and someone can memorize it using banana never rot, and then later he gets to the real meaning of base number remainder in that way. Now, the question is, to which base are we converting? We are converting to base 5. That's why 5 is here. And now, which number are we converting? It is 34, it's written here. And now, table 5 works in your division. So now, 34 divided by 5, you will find out that it is 6 times. 34 divided by 5 is 6. Why? 5 times 6, you get 30. So meaning there's a remainder. Why? 5 times 6 does not make 34, but makes 30. Meaning 4 remains. So write it as a remainder. So write it here. And now I've got 6. 6 is again greater than 5. The base we are dealing with here. So we still divide by 5. 6 divided by 5. So write a 5 here. It says 6 divided by 5. That is 1. I said 6 divided by 5. That is 1. Remainder 1. 1 remainder 1. And then we write the answer upwards. We write the answer upwards. From the last remainder to the first remainder. Why can't we continue dividing? This remaining number is no longer equal to 5 or greater than 5. So therefore you can no longer divide, because 1 divided by 5, you cannot give anyone anything in terms of a whole. And here we're dealing with a whole. So we write the answer upwards for the remainders. So the last remainder is this one, because it is not divisible, so it cannot be divided by 5. So we go 1, 1, 4, base 5 is the answer. Teacher will repeat. I said, when you're given a question like change 34 base 10 to base 5, you are going to divide. Remember, we expanded through multiplication. Here we do the opposite of multiplication. That is changing from base 10 to other bases. We divide. You write base number remainder, which I said one can recall using banana never wrote, but the actual meaning is base number remainder. The base is that one you're required to change to. So we are converting to base 5 is the one you write. The number is 34, and now divide. 34 divided by 5, because there are 6 times. Why? 5 times 6 you get 30. And now 4 remains undivided, so it's a remainder here. So that is 6 remainder 4. And now 6 being greater than 5, we can continue dividing by the base we are dealing with. That is 6 divided by 5. Because there are 1s. And 5 times 1 get a 5, meaning 1 remains here. So 6 divided by 5 is 1 remainder 1. So you write it here, and then you look at 1 and the number you're dividing by, which is 5. If it's less, don't continue. It will make the last remainder. Then the answer will be written from the last remainder to the first remainder. The first remainder was 4, and the last remainder is the 1. Remember, this 1 is not divided, therefore it remains undivided. So it's the last remainder. Then write the answer going up, that's upwards. 114 base 5. 114 base 5. And that's all. And that's the answer. And then look at example number 2, which reads or tells you to change 8 base 10 to base 2. Change 8 base 10 to base 2. Now, being that 8 is a base 10 numeral, we are then going to divide through use of base number remainder. Banana never wrote. Base number remainder. So the base to which we are converting or changing is base 2. Write a 2. The number we are changing is 8. And now we divide. 8 divided by 2. That is 4. Why? 2 times 4 is 8, meaning there is no remainder. So 8 divided by 2 is 4 remainder 0, meaning there is no remainder. So with or without a remainder, you must write something here. Now there is no remainder, but you write a 0. So 8 divided by 2 is 4 remainder 0. So write a 0 and then continue and see. 4 is still greater than the base, so we divide. So 4 divided by 2 is 2 remainder 0. 2 remainder 0. So remainder is on there, you write a 0 there. And then we look at another number here 2. So anything equal to a base or greater, we continuously divide. That is 2 divided by 2 again. That is 1 remainder 0. So I've found out that there hasn't been any remainder here. So with or without the remainder, you must write something here because the remainder makes the answer. So when you don't have a remainder, write a 0. And then you write the answer upwards. That is from the last remainder to the first remainder, that is 1, 0, 0, 0, base 2. Someone can say 1 triple 0 base 2 to save time. 1 triple 0 base 2 or 1, 0, 0, 0 base 2. You need to be repeated for. I said the question says change 8 base 10 to base 2. You say base number remainder. The base to which we are changing is base 2. Write our 2 here properly, and the number we are changing is 8. And now start dividing. 8 divided by 2 is 4 remainder 0, and then 4 divided by 2 is 2 remainder 0, meaning there is no remainder. 2 divided by 2 is 1 remainder 0. And now having reached 1, which can no longer be divided by 2, it's the last remainder, then write the answer going up, that is upward way. That is 1, 0, 0, 0, base 2. So 8 base 10 is equivalent to 1 triple 0 base 2. And that's all. Then we look at how one can add the bases, having learned about place values, about expansion, about changing one base to base 10, and from base 10 to another base. Those around 4 subtopics in this very lesson. Now, go to fifth. Now, addition of bases. We are going to look at how one can add in base system. And example number 1 says, add 143 base 5 and 232 base 5. Now, the question has been horizontally arranged. We normally arrange the given work that is vertically to respect the place values because they are the ones we are dealing with now. So we write 143 base 5, then under it we say plus 232 base 5. Remember to write the base, and now here you first write the base 5 at the answer. And now you will have to know what I'm about to say. In base system, we use only those whole numbers that are less than that base. For example, base 5, we use 5 digits, that is 0, 1, 2, 3, and 4 as the answer. We shall never write a 5 or a 6 or anything beyond that. That is 5, 6, 7, 8, 9 as digits will never be written. So the digits we write in base 5 are 5. They are equal to the number 5. So they are 5 in base 5. That's 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. So when we add and get an answer that is equal to 5 or greater, we are then not allowed to write directly. We first divide and get the outcome, and of which the remainder makes the answer, like we're going to see. So that we have got 143 base 5 plus 232 base 5. Be mindful of the place values. This is ones, this is 5s, this is 5 5s. Without necessarily writing them, but order them like we did in base 10. In that order, write the base, because when you forget base 5 here, your answer will be wrong. It will automatically turn to base 10. Because I said any number without a base is a base 10 numeral. But here we are dealing with base 5. So if you don't put a base, you will have added for nothing. Now we are going to add 3 plus 2 is a 5. 3 plus 2 is a 5. Like I said, a 5 cannot be written in base 5. The possible answers range from 0 to 4. Only 0, 1, 2, 3, 4 make answers here. So you cannot have 5, 6, 7, 8, and 9 as digits written in base 5. So now that 3 plus 2 is a 5, I told you first divide what we have got here, a 5, divide by the base 5. So we say 5 divided by 5, you get 1, remainder 0, meaning no remainder. So we write the remainder here 0, and then regroup this 1, the one you say carry 1. So regroup 1 to the next place value. I say 3 plus 2 is a 5. Never write a 5 in base 5. So we go 5 divided by 5, that is 1, remainder 0. Write that 0 and regroup 1 to the next place value of 5. So we go 1 plus 4 is a 5, and a 5 plus 3 you get an 8. So that 8 is not allowed to be written as a digit in base 5. You instead divide by the base we're dealing with, that's base 5. You say 8 divided by 5, you get 1, remainder 3. 1, 5, remainder 3. And now, remember, we write the remainder and regroup the quotient. So write 3 and regroup 1. So that's why I wrote 3 here, and then regroup 1. The one you say carry 1 if you wish. So you regroup 1 and then add and see. 1 plus 1 is a 2. 2 plus 2 is a 4. This time round, 4 is one of the digits allowed in base 5. So it's written directly. Please don't divide, because this is one of the acceptable digits in base 5. Repeat this number. The question tells you to add 143 base 5 and the 232 base 5. The first thing is to order that number vertically, meaning downwards, according to your place values of 1s, 5s, and 5s but don't write the place values, but do order. So you say 1, 4, 3 base 5 plus 2, 3, 2 base 5. And in putting this sign equals, you write the base 5. Don't forget the base. You write before you even add, because when you forget, the answer will be wrong. You have added in base 10. So now, in base 5, we write all those answers that are less than 5. That is 0, 1, 2, 3, 4 only. 0, 1, 2, 3, 4. In base 6, you write only 0, 1, 2, 3, 4, 5 as answers. In base 7, you write 0, 1, 2, 3, 4, 5, 6. In base 2, you write 0 and 1 only. 0, 1, 0, 1 only. So, when you get a sum or an answer here that is a 5 through addition, in base 5, you are not allowed to write a 5. Like it is here, 3 plus 2 is a 5. You get that 5 you have got and divide by the base. So that's 5 by 5, that's 1 and no remainder. The no remainder means 0. So 1 remainder 0. You write 0 and regroup 1. So write 0 and regroup 1. Up here, you say 1 plus 4, you get a 5. 5 plus 3, you get an 8. Now, that 8 cannot be allowed because it's greater than 5. So 5 and greater, you divide for that particular base. That is 8 divided by 5. This 5 is the base we're dealing with, which is equal to 1 remainder 3. Write 3 and regroup 1. Write 3 and then regroup 1. Where 1 plus 1 is a 2 plus 2, you get a 4. Which 4 is acceptable in base 5. So the answer is 430 base 5. And that's all. That's the answer to that question. So doing, we have reached perfection. Then the last example about addition tells you to add 1 3 base 5 and 1 1 base 5. Do the same. We write 1 3 base 5 plus 1 1 base 5 in the vertical way, and then write the base here, base 5, where 3 plus 1 is the 4. Which 4 is allowed? This time you write a 4 directly, and then 1 plus 1 you get a 2. Which 2 is allowed? So the answer is 2 4 base 5. So this one doesn't need anything like division, because all the answers that come out of the direct addition are actually acceptable in base 5. That's how we do all that much. I am teacher Katimbo Richard that has taught you. For more information about the same work, let teacher Katimbo be called on 0776 251655. I repeat, 0776 251655. Alternatively, on Airtel line 07572 33066. I repeat, 07572 33066. And that is the end of the lesson for today. We meet next time. Bye bye.